Alright, this problem is asking us for weight and balance, and it's asking how much weight do we need to add to location Y in order to balance this plank. So what we're given is that at X we have 50 pounds, and at Z we have 100 pounds. So remember, weight times arm equals moment. So the total moment on this side has to equal the total moment on this side. So for X, box X, we have weight is 50, and the arm is 50 inches from the datum line. Weight times arm equals 50. Now we also have to do it for Y, and we don't know the weight of Y, so we're just going to leave that as a variable, Y, but we do know the distance is 25. And so that's the total moments on the left, and that has to equal the weight times the arm on the right. So 25, 50 times 50, 2,500, plus Y times 25 equals 10,000. That's the same, so if we subtract 2,500 from both sides, now we have Y times 25 equals 7,500. And if we divide 25 by both sides, then we have Y equals 7,500 divided by 25 equals 300 pounds. So that's how you would do it by hand, but let's look at how we would do it using the E6B. So when you're working this problem on the written, so remember we've got 50 pounds here and 100 pounds here. On the written, you're going to be given three choices. You're going to have about maybe 30 pounds, 50 pounds, and then 300 pounds. So what I would do, if you weren't sure how to do this problem by hand, I would work the problem backwards, and I would find the middle number to start with. So 30 is the lowest, 300 is the highest number, 50 is the middle number that we can start with. Now, if we use the middle number, if it's too much weight, we know that 30 is the answer. If it's not enough weight, we know that 300 is the answer. So what we're going to do is go to the E6B, and we're going to use the weight and balance function. So what we're going to do first is we're going to determine the center of gravity using with only box X and box Z, determine where the center of gravity is at. Now, because we've made the fulcrum point here, because the datum line is right here, this datum line effectively is the center or zero location. So we know if this is 0, it's about 50 inches to, in this direction, 100 inches to here. Now if we're going backwards, now we have to use, for the E6B, if we're going backwards from 0, we have to use negative numbers. So here it's going to actually be negative 25 and a negative 50 distance. In some aircraft, the datum line will be located in such a way that oil located in the engine actually has a negative arm location from the datum line. So you could see negative numbers in aircraft weight and balance also. But for here, we're going to use the 0 as the datum line. Going to the left, distances will be negative. To the right, distances are positive for the E6B weight and balance. So first thing we're going to do, we're going to get weight and balance. We are going to determine the center of gravity using X and Z first. So weight and balance, we are given weight and arm information. We're going to start with weight 50 pounds being added at station 50 negative. Reduction factor 1. Second weight we're going to enter is Z, and Z has 100 pounds. at arm station 100. So what that does is that tells us our center of gravity is currently at 50 inches. So here at 50, this is currently where the plank would balance at. Okay, so now we have weight X and Z. Now we're going to add weight Y, 50 pounds at negative 25 inches. So currently we're seeing 50 inches is the center of gravity with only X and Z on the plank. Now we're going to add weight Y. Weight Y, we're going to start with 50 pounds. And the arm distance is going to be 25 negative. And that gives us a new center of gravity of 31.25 inches. So it moved, the center of gravity moved from 50 inches, and it moved left a little bit to here, which would be 31.25 inches. Well, and that's with only adding 50 pounds. So what that tells us is that by adding 50 pounds to station Y, it did not move the center of gravity far enough to balance the plank right here. So that tells us that we need to actually add, the correct answer would be 300 pounds to go ahead and move that in. So we can continue on from here. So what we can do is we can actually, we'll start over. We'll go ahead and clear this one out and verify that 300 pounds is the correct answer. So the first thing we're going to do again is we are going to determine the center of gravity with only boxes X and Z. And again, we saw that was 50, but let's go ahead and get those weights added so we can calculate the weight and balance. So weight, we have 50 pounds entered at station negative 25, or no, station 50 negative. Reduction factor 1. And then we add 100 pounds at arm station 100. So with X and Z added, we can see that, yes, our center of gravity is still 50 inches from the datum line, right here. So now let's go ahead and add 300 pounds at station Y. So 300. Station location is 25 negative. And now what we can see, the center of gravity location is 0. So that tells us that it's balancing exactly where we have identified 0 at. So 300 pounds at location Y balances the plank at 0. So I'm going to take this one step further in explanation. So again, we've got 50 pounds at X, 100 pounds at Y. What's important to know when you're doing weight and balance is it doesn't necessarily matter where you measure from on your datum line. So before, the datum line was at the fulcrum. We said this datum line represents location 0, and we measured left and right from location 0. Positive to the right, negative to the left. Well, as long as we are measuring everything from the exact same location, it doesn't necessarily matter where the datum line is. So for example, if we wanted to declare that this red line was a new datum line, or let's see, this blue line is a new declared datum line. We are going to declare this now is location 0. So what does that mean for our problem? Well, for our problem, that means that location X is no longer, so before location X was 50 inches away from this red dotted original datum line. Well, now what it means is that box X, arm distance from the datum line, our new datum line here, it's actually on the datum line, so its distance is 0. Box Y, again to the right, is positive, so box Y is at location 25. Where we want to balance at is at location 50. So remember, before it balanced at location 0, but now it's balancing at location 50 measured from this datum line. So here's location 50, and then all the way out here, we'll have, instead of location, this line out here will be 200 inches now, or 150 inches total from the new datum line. So we can work the problem the exact same way on the E6B. So we're going to do weight and balance. We're going to again add weights X and Z. So weight X is 50 pounds at location. Now remember, the new location is at 0 because the weight is located on that blue line, the new datum line that we've drawn. Reduction factor 1. Now weight 2 is 100 pounds located at station 150. And what you'll notice is that this gives us the center of gravity at 100. Okay, well, if here's the new station 50, station 100 is going to be right here. But if you'll notice, this is the exact same location where used to be station 50. So no matter where we measure from, if we measure from the original datum line, the lever balanced at station 50. If we're measuring from the new datum line, it balances at the exact same location. It's just that the number has changed because we're measuring from a different location. So it's balancing from the same point. It's just the number we use to represent that point has changed. So now we're going to continue on. We're going to add weight, 300 pounds. Now the distance we're adding the 300 pounds to is 25. So now what we get after adding the weight, 300 pounds at Y, our new center of gravity is located at station 50. Well, station 50 is now at the exact same location that station 0 used to be at the original datum line. So again, no matter where we measure from, as long as we are measuring consistently using all the weights, the location of the number where it bounces will stay the same. So that's a little bit more advanced when it comes to weight and balance. When it comes to the aircraft will be very similar. In some aircraft, the datum line could be in the center. You could have negative numbers toward the engine and negative numbers such as oil in front of the datum line, positive numbers such as passengers, fuel, baggage behind the datum line, or there may actually be some aircraft that have the datum line so far forward, such as this new datum line that we drew, that all numbers and weights are positive to the right.